Hi, Algebra 1 students. This is our quiz review. I want to take a look at these 4 questions, of which we actually did take a look at in class, but maybe not as thoroughly. So let's take a look. Problem number 1. It says solve m squared minus 2m minus 3 equals 0 by graphing. So we're going to go ahead and we'll pull this up, is we're going to write down the function. And I do recommend that you also write down the function m squared minus 2m minus 3 equals 0. Now, when the directions do say to graph, we are going to go ahead and do all the same types of things that we've been learning, particularly where we identify the a, the b, and the c value to start with. The a value, of course, is the number in front of m squared, so 1, b, negative 2, and c, negative 3. If you recall, this comes from the following equation, ax squared plus bx plus c equals 0. Once we establish a, b, and c, we'll go ahead and find the vertex of our parabola, because that's what the graph of this particular function will be. The vertex will be negative b over 2a. Once we get that quantity, we'll then plug it in to find the y-coordinate. Let's go ahead and do this. I'll use v for vertex, so negative b, so negative of a negative 2 over 2 times a. So we have negative of a negative 2 over 2 times 1. That becomes positive 2 over 2, which in turn becomes simply 1. So 1 comma what? Well, we now plug in 1 in for m in this equation, m squared, so 1 squared minus 2 times 1 minus 3. Now we're solving for y. I know the original equation was set equal to 0, but that was just helping us identify the fact that we're going to be solving this, or expand this. So we go ahead and solve. We get 1 minus 2 minus 3, or what? 1 minus 2, negative 1, minus 3, negative 4. So my vertex y-coordinate is just that, negative 4. I do ask that we make 3 points at least when we draw a parabola. The first point, as you can see here, 1 comma negative 4. And we like to surround the point, 1 negative 4 with a point 1 less than, and maybe 1 greater than 1. 0 and 2 are both fantastic. As a matter of fact, plugging in 0 is great because 0 squared is 0. Minus 2 times 0, that's also 0. So 0 minus 3 yields simply negative 3. Because 2 is the same distance from 1 that 0 happens to be, that will also have a y-coordinate of negative 3. So let's graph. Now keep in mind we are solving. When it comes to solving, we need to be mindful that we want y-coordinates that are equal to 0. So far we don't have that. But we might actually have only a couple more points to find to calculate the x-intercepts. In other words, solving the equation. So 0, negative 3, 1, negative 4, and 2, negative 3. Okay, so I am going to go ahead and find 2 more points. I'll find 1 more point that it happens to be less than 0, so negative 1, and 1 more point that's greater than 2, so 3. So if I plug in negative 1 back into the original expression, negative 1, quantity squared, minus 2 times negative 1 minus 3. Again, we're solving for y, that's 1, minus 2 times negative 1, or plus 2, then minus 3, well that's 1 plus 2, 3, minus 3 is 0. So we do in fact get what we wanted in that we've got a y-coordinate of 0. Because 3 is the exact same distance that negative 1 is from the vertex, that's also going to have a y-coordinate of 3. You can plug it in to check, but it will. 3 comma 0, negative 1 comma 0. Here's your parabola. The answer to this question is just what we just discovered as x equals negative 1 and 3. Let's move on to the next question. Next question was to solve again by graphing. W squared plus 5w minus 1 equals 0. It also says that if integral or integer, as we saw in class, roots cannot be found, estimate the roots by stating the consecutive integers between which the roots lie. Let's go ahead and start this process. I'll write down the problem again. So very much like problem number 1, we're going to go ahead and identify all the key components in order to graph. my A, B, and C. A being 1, B 5, C negative 1. So the vertex will be negative B, or negative 5, divided by 2 times A, or 2 times 1. This then becomes negative 5 halves. And then my y-coordinate of my vertex, I will have to do some extra math here, plugging in negative 5 halves for W. That quantity squared plus 5 times negative 5 halves minus 1. And again, I'm solving for y. This time I will use my calculator to help here. So I'll type in parentheses negative 5 over 2, or you can type in negative 2.5, that quantity squared. And then again, we had plus 5 times the quantity negative 5 halves. And then lastly, minus 1. Okay, so negative 7.25, or as a fraction, negative 29 fourths. Okay, so I'll write down negative 29 fourths. And we see that, of course, as well here in our representation for the x and y coordinates. I make my xy table, and I'm going to have my vertex, as I just discovered, at negative 5 halves, comma negative 29 fourths. If I think about kind of ahead of time here how this is going to take shape, thanks to what the value is there for my vertex x coordinate. Negative 5 halves is 1, 2 1/2, so negative 2 1/2 there. And then 1, 2, 3, 4, 5, 6, 7, and a little bit more, so negative 7.25 roughly there. So that's my vertex. If I go ahead and pick a number like another integer just to the left, an integer is very smart here to choose negative 3, but also negative 2. I can do that rather quickly simply by going back to my calculator. I'll be somewhat quick about it by hitting second enter a couple times. The TI graphing calculator is very nice in this respect. So we'll have negative 3. The same function, of course, just typing in though instead of those previous values we'll have here negative 3. So negative 3 quantity squared, and then plus 5 times the quantity negative 3, and then minus 1 yields negative 7. The same thing should hold true when I plug in negative 2. You can check that if you'd like, but that will be the case because, again, negative 3 is the same distance from negative 5 halves that negative 2 happens to be. So we'll go ahead and plot negative 3, negative 7, and negative 2, negative 7, which is pretty close to this vertex point. And we can keep going. Certainly I don't have enough points to see where this parabola is going to cross the x-axis, so I'll pick some other values. 3 is usually enough just to get a basic picture, but because we want to see where it crosses the x-axis, we'll need to continue this. I'll pick 2 numbers less than negative 3. I like negative 5 and negative 4. And I'll pick 2 numbers greater than negative 2. I like negative 1 and I like 0. If I plug in negative 5, we'll go back to my calculator here. And I'll type in negative 5. And I'll type in back here as well negative 5. And I'm going to get negative 1 as a result. Negative 5, comma negative 1, but also 0, negative 1. And then negative 4, same type of thing. Now I've already done this prior to. I was playing around with the numbers here, but you can see here negative 4 will yield, as you see above, negative 5. So this should actually be enough. There we go, negative 5. This should be enough to graph and to see, in fact, what we want to see. Negative 5, of course, being the same y-coordinate for negative 1, because negative 1 and negative 4, just like 0 and negative 5, are the same distance from negative 5 halves. So 1, 2, 3, 4, 5, comma negative 1, 0, negative 1, which is very easy. I probably didn't need a calculator for that. Plugging in 0, 0 squared plus 5 times 0, 0, so that whole thing becomes 0, then minus 1, 0, negative 1. Negative 4, negative 5, 2, 3, 4, 5, and negative 1, negative 5. So my parabola will nicely take shape. And because this problem was all about finding where the graph crossed the x-axis, we can officially say, and we're still approximating, but officially say that our answer is here and here. This point looks to be between -6 and -5, and this point looks to be between 0 and 1. And that's how we finalize our approximate answers as far as between particular integers. Moving on to the next question. Use a quadratic equation to find two numbers that have a difference of 3 and a product of 10. So I'll go ahead and write down here, I'll write down my setup for what they're asking. They are wanting a kind of two equation setup. The first equation we'll go ahead and write as such. The difference of two numbers. So we'll call one x and the other y. These two numbers subtract to yield 3, the difference being that. Now the product of the two numbers, still x and y, is 10. We saw problems like this in the past. We did have to use a strategy called substitution, in which we are going to take one of the two variables and one of the two equations. I'm going to pick equation 1, as you already can see here. So equation 2. I'm going to get a variable by itself. To do that, I'll simply just add y to both sides on equation 1. Therefore, from here, this expression in that equation, this is my substitute, and this expression will now go in place for x into the second equation. Okay, and now what we'll do is we'll rewrite this equation as such. So it becomes y plus 3 times y, and that equals 10. When I solve, I distribute y, so that y squared plus 3y. I'll subtract 10 now, setting it equal to 0. Instead of solving by graphing, I'm going to solve by factoring. Now, I want to highlight the fact that any time you guys have a quadratic that is factorable, even if you're asked to graph, you should also see if factoring is something you can do. If it is factorable, you should do it. And still graph if you're asked to, but this is nice because you're going to be able to see the answer right away. Two numbers that multiply to -10 and add to +3. Those are going to be 5 and 2. 5 is going to be positive, 2 is going to be negative, 5 minus 2 is 3, while 5 times -2 is -10. I could have made a sum and product table to do this, and I could have also split the middle term, but I figured here on this problem, we're doing enough factoring where I think you can do this without that. Set each factor equal to 0, this being now -5 if you solve, and this being 2. So I'm almost done with my answer. I just have to go back and plug in y equals 2 for this, so x equals y plus 3, so 2 plus 3, therefore 5. And I'll plug in my other answer there, so x equals -5 plus 3, or -2. So I do have two answers. X equals, for what I just came up with, when I plugged in -5, I got -2, and y equals -5. And then the other two answers, when y equaled 2, I ended up with 5 for x. So when x is 5, y is 2 on that particular solution. So there's two answers, one of which is -2, -5, and the other 5, 2. Let's move on. Solve this quadratic by graphing. What I would like to do to kind of kick the problem off here is rewrite the problem by setting it equal to 0. We'll do that first. Slide this up a bit. So then we'll see the following. We shall see if I subtract 21 from both sides, x squared plus 2x minus 35 equals 0. Now this is crucial. Anytime you are asked to solve a quadratic, whether we factor or not, I think I will actually factor before I graph. Let me go ahead and do that. Two numbers that multiply to -35 and also add to 2. Those will be 7 and 5, of which this will be positive, the 7 and the 5 negative. 7 minus 5 is 2. 7 times -5 is -35. Therefore, x is -7 and x is 5. I will continue in another video to graph, but I want to highlight the niceness of how this problem could have been solved by factoring. Factoring before or after a graph is smart. You almost always ensure that you get the answer correct.